So, we left off on our orca problem. So one of the big things that we were practicing here is how do I convert this formula to what we want to solve for. So we want to turn my dirt formula, my d equals rt, into a formula relative to t equals. So our goal here is to get t equals something that then I can use that to solve for any time I come across. So if I start with my dirt formula, what do I need to do to get the t by itself? Longer?
Well, the formula would be t equals.
Back yourself up. What do I need to do?
T, but you have to divide r on both sides.
Yeah, we have to divide by r. Be careful, we want to put that by in there because it kind of keeps the order straight. So we divide by r on both sides. And that then gives me that t, well, t would be on the right side still if I keep my left and my right side straight. So then t equals d divided by r. So guys, this is a formula that you can use anytime you have a distance and a rate. Your time will just be the distance divided by the rate, or how fast you're going. So we're going to take that formula down into here. Say, okay, time is distance divided by rate. Do I know the distance that they're trying to travel? Well? 26,400 feet. So we put that on top. Now what you want to make sure is that your distance length is the same as the length used in your rate. And because it's feet per minute, what do I know about my time? When I get my time, it's going to be, Cassidy?
704 feet per minute.
Okay, so that's my rate, so that goes on bottom. But because I see, and that kind of looks like a 6, because I see that it's feet per minute, what do I know about the label of the answer that I'm going to get here? Oriana? It's going to be in minutes. So your time is always going to have the label that comes from, I need to orient this, that comes from our rate. So feet per minute, my feet matched in both the distance and the rate. So then when I do that division, who's got it for me? 37.5. So that means, guys, it only takes them a little over a half an hour to go 26,000 feet. That's far. If we convert that to miles, how would I convert to miles? How many feet are in a mile? Did someone steal my calculator?
I did.
Oh, I took it to math counts yesterday. Forgot about that. How do I convert feet to miles? What is my conversion factor, the relationship? How many feet are in a mile?
I can see this. Like over 5,000. It's on the back of our plans.
Here's how you remember it. 5 tomato. This is how you remember how many feet are in a mile. 5 tomato, because it's 5,280. 5 tomato, that's how many feet are in 1 mile. 5 tomato, that's how you can remember it. 5,280. So to convert those feet into miles, we just take 26,400 feet and divide it by the 5 tomato. 5,280. Guys, this is 5 miles. They can swim 5 miles in a little over a half hour.
About 10 miles per hour.
Yeah, they're probably closer to 9. We'd have to round down a little bit. But yeah, they're swimming at about 9 miles an hour. That's pretty fast. That's faster than most of you could run. Most people can run at about 6 miles an hour. Is a pretty standard pace. Like, really on a treadmill, like you checked it?
I think I did.
Because that's pretty fast.
Yeah, I'm fast.
Yeah, do that. Could you do that for 5 miles though? Do you think you could keep that? That's exactly. So orcas, pretty crazy. They can.
If they can do it, I can do it.
Oriana, you've had your hand up. You got a question?
No, just medicine breakfast.
Yes, breakfast already happened, but I do need to take my heart pill. All right, so try this. We want to solve for B, but I'm curious if any of you guys can realize what would be the easiest thing to start. And a lot of times this year when we've worked with mixed numbers, this has been our first step because it makes life easier. When we've worked with mixed numbers, Thomas?
We make them into improper fractions.
make it into an improper fraction. So take both those mixed numbers, make them improper to begin with. Now it wants me to write a problem that can model this. Write a problem, like write a word problem that would relate to this and then solve it. So hopefully your impropers are 5/2 B and 15/4. Hopefully that's what you got as your impropers. If you forget how to do that, remember it's the, I was tutoring somebody last night and they said that in elementary they apparently call it the triangle method. Because you take your 2, multiply by this 2, add it to here. Yeah, so I really like to look at it as 2 times 2, then plus 1. But however it helps you remember it. Yeah, so whatever helps you remember, as long as we can do that. But so we need to write a word problem. We're not going to solve this yet. We're going to try to write a word problem. So we have 2.5 times b equals 3 3/4.
You could convert the 5.5 B to 10 B.
So we could. I'm not going to though, because when we go to solve it, you'll see how easy this. I don't even need to convert that. But b, being a variable, has to represent something that I don't know, right? So what could this b represent? Eli? Bagels. Sure. Like we've been using this chapter, we could say that b is bagels, but then how can I make that 2.5? What about bagels? It's not, because that can't just be 2.5 bagels. B would have to be like the price of the bagel or the weight of the bagel or something like that. Thomas?
So, each bagel costs $2.50.
So B would be the number of bagels then?
Yup.
So these are some really fancy schmancy bagels, or you're at Starbucks, because everything's overpriced at Starbucks.
No, it's not.
So B will be the number.
It is.
We're not getting into a debate. You guys don't really pay for your own things. Once you do, come back and talk to me. Yeah, with money that you earned from your job.
No.
Yeah, exactly.
Yeah, I use it.
So we're gonna say B is the number of bagels. And then, so so Thomas, if you made this dollars, and this is number of bagels, then this solution value would have to be dollars also. So this is going to be a little weird. I think I'm going to get a partial number of bagels, but that's okay. The big question here is, how do I get the B by itself? What, Divine?
Reciprocal.
What do we do with the reciprocal? Isaiah?
You multiply it by on each side.
Yeah, now which reciprocal are we going to use? Are we going to use the reciprocal of 5/2 or the reciprocal of 15/4? 5/2 because it's attached to the B. So on both sides, I'm going to use green since I've already used red a little bit today. We're going to multiply by 2/5. We're going to multiply by 2/5. Now on the left side here, these cancel and I get just B. And on the right-hand side, I can cross-reduce.
Oh, yeah.
So what cross-reducing can happen there? And there's actually a couple different ones. Cassidy?
So you could cross reduce
The 4 and the 2, what's my common factor there? 2. So I divide them both by 2. I get a 1 up here and a 2 down here. What other cross-reduction can be done? Eminal? 15 to 5. And what's my common factor there? Ooh, that'd be a factor of 15, but that's not a factor of 5. 5's my common factor. I divide by 5 there, I get a 1. Divide by 5 there, I get a 3. So really, these ones don't do anything now. I really have 3 on top and 2 on bottom.
So B is equal to 1.5.
1.5. So I can either write it in mixed form, 1.5, or I can write it in decimal form, 1.5. So using this problem, if our B is number of bagels, I was only able to buy 1.5 bagels. Didn't have enough money to get that whole second bagel. Only bought a half. Now the question is, did you cut it this way or did you cut it this way? You want like the top of the bagel? I think the top's always the best.
I like the bottom.
Karina?
So I did something different. And I know
Hold
you're
on,
not
Karina
gonna
did
like
something
it.
different. It's
I know
okay.
you're not gonna like it, I know. But I just did like, so when it was like 5/2 before where we did the reciprocal.
Yeah.
And 15/4, I just did like the what's that thing where like this and this and this, like 2 times 2 is 4, and then 5 times 3 is 15, which is also 3 2.
You looked at what B. You kind of set it up like a proportional relationship. What would B have to multiply by to make it equal to 15/4? That's fine, but not every problem will work out that nice. This was really nice because the 5 and the 15 share, and the 2 and the 4 share. They're like common factors. But yeah, I mean that works here. Just make sure you understand the other process, the multiplication with the reciprocal. Any other questions on this one?
No.
Luke?
We kind of solved this a different way too.
Okay.
So I actually divided 3 3/4 by 2.5, and I still got 1.
Okay, you can. Like, we could rewrite this as 2.5b equals 3.75 if I make my fraction forms into decimal. And then that would make more sense to just divide by 2.5 on both sides. So again, that's another way, many right ways to get to Florida. But as long as you got the same answer, then you're cool. Any other questions? Try the got it on your own. You need to write a problem. So the first thing you have to ask yourself is, what is the R going to represent? What is my unknown value going to represent? And they say write a baking problem. It doesn't necessarily have to be a baking problem, but if you're a baker, I would love to hear what problem you're going to write for this. I'm going to orient the screen while you guys are working on this, so please quietly do it on your own. You got a minute or two to do it on your own.
Band-Aid.
Band-Aid, yeah, I got
I
that.
think I have a splinter.
Oh, well, you don't need a Band-Aid for a splinter.
I don't know if it's a splinter or not.
You actually don't want to put a Band-Aid on a splinter because your body
I can't tell if it's a splinter or what it is.
your body will naturally try to push it out. So don't worry about it. Just quit messing with it and that'll be the best thing possible. So you guys should be, even if you can't think up a problem, go ahead and solve this. But those of you who are creative should be able to think up a situation that would represent this. Half of R, half times R, is equal to 1 2/3. Half times the R is equal to 1 2/3. What do we do on both sides to get the R by itself? What could the R represent? Come on. You can grab a seat if you want. I know a bunch of people think of language arts, so you can browse around wherever you want. We're wrapping up a lesson from yesterday and then taking a little survey things. Pretty soon this will be pretty boring.
I like math, so
Yeah,
it's not boring today.
I like math too, a lot. These kids think I'm crazy, but
No, I love
we
you.
don't.
I'm crazy.
Please don't have me do crazy.
hey, hold on. I'm curious. Who can paraphrase short explanation,
Yeah.
what we talked about at the beginning of class yesterday? Who can tell? Was it Arzo? Who can tell Arzo what we talked about? The math application right now. Thomas?
We're making math applications to
What's going on right now?
making math applications
Oh, we're not.
to
The drawings on Wednesday. What was it?
I forgot.
Eli, help him out.
Were we talking about the chances of getting a winning Powerball ticket?
Yeah, we were talking about probability because Powerball is a big deal right now. So we talked about how they're more likely to drown in the bathtub than they are to win the Powerball, or more likely to get hit by a bus or struck by lightning. So just applying that whole like, how good are your odds to actually win? Because everyone's crazy buying Powerball tickets. All right, does anybody have a situation for this problem? Cassidy, your hand shot up. What did you make R represent here?
I made represent
Reese's
Reese's cups.
cups. Okay. So is it number of Reese's cups or weight of Reese's cups or what is it?
The amount to buy.
What is it?
The amount to buy.
So like cost.
Yeah.
Okay, so cost of. So then what we're saying is half. So you bought half a Reese's cup or half a package maybe. Like maybe you and your friend split the half a package. And actually, I heard that one of the teachers here, I think it was an 8th grade teacher, because they love Reese's cups, somebody got me like a 1 pound Reese's cup or something like that. So they do make different sizes of Reese's cups. So half my Reese's cups. Cassidy, what'd you do to 1 2/3? What is it improper? 5 over 3. And what'd you do to solve for the r? Isolate that. Brennan. Yeah. What's the reciprocal of 1/2? 2 over 1. And really, you can just think of this as, well, if I double a half, I get a whole. So, yeah, we can put it 2 over 1, but we don't really need that. We're really just multiplying by 2. Now, over here, it's nice to put it in fraction form, so I can work straight through the top and straight through the bottom. So what did you get for your solution of r?
I got 3.5.
Yeah, because if I multiply straight through, I'm going to, 10/3, so we get 3 and 1/3. So, Cassidy, what's that get when you round up the decimal? $3.34. So maybe this is that giant 1 pound Reese cup, and half of it costs, so R, since that's the cost of the whole thing would cost $3.34, but half of it only costs 1 2/3, which actually, if we looked at that in decimal form, it'd be 1.67 rounded. Now this, really, when you look at 1/3, what's the 1/3 decimal?
3.33.
So that'd be 3.3 repeating, which really, would we round that up or keep it at 3? We'd keep it at 3, so instead of 3.34, I'd really rather it be 3.33. And since it's money, we'll stop right there. Now, the only other thing of why you might have rounded up, what in your head made you round up?
Well, because like the shops like to round up.
Yeah, stores like to round up.
Because they want the extra.
They want that
They
extra.
want the actually juicy.
So, when you're looking at a cash register situation, it might round up no matter what. But when we doing the math application, we're going to keep it at the 3. Cool? Any questions left from 8-5? Luke?
Okay, so I have actually gotten one of those 1 pound Reese cups.
Yeah? Do you remember how much it cost?
Not really.
Our situation's probably not very realistic because it's hard to make a situation.
I'm pretty sure it was about $5.
Yeah.
I have another-
So this is close.
I have another story.
It's huge. Okay.
It's like
I have another
Oh,
story.
it's that big.
All right, so now, guys, what I need you to do is grab laptops here. We should have 15 in there. So 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm going to go grab a few extra from Gold Ring. I'll be right back.
I got your computer. Baby, come back. You could have said
No.
Come on.
All right, who else needs a Chromebook? Oh, yeah. All right, you need to go to Schoology. Navigate your browser to Schoology. Yeah?
It took like a week for me to eat
Yeah, well, hopefully you don't eat it in one sitting.
I would eat
It actually reminds me of something. It actually reminds me of something.
All right, guys, navigate to Schoology.
I'm already there.
Once you go, yeah.
I googled it. The 1.2 pound Reese cup cost $5.
That's not that bad, actually.
I was
That's pretty good. So maybe, thank you for that. Maybe with our situation, it was on sale. Like an end. Maybe it was old and they needed to get rid of it. So right here, student experience survey. Now, when you click on this, you might need a code. It might ask you for a code. If so, that's the code right here, OH314262. I will leave my screen up. But when I tried this morning, it did not ask me for a code.
might be because you're
Give me a second. Here, I got you guys. That door is kind of a trick.
So I forgot. I was in a machine, so I'll have to figure
Would you like be quiet?
So when you click on the link, it should take you to a survey. Now it says that Mr. Shurg is your teacher. It's not correct. It doesn't matter. It's going to say that Shurg is your teacher, but that's fine. Took you right there. So, all I need you guys to do is work through the survey and answer the questions honestly. Then when you get done with that, this is your time. So you can work on your digits homeworks. You can work on the review for chapter 8 that's in there. I highly suggest trying some of the problems in the review. Or you can work on anything else for school if all of your math is done. So you have to have 8.1 through 8.5 done before you can do anything else. Questions? Cool. I will turn on some music so we can get some good ambiance here. Ambiance.